All right, I'm Raffael. I work for a company called ArcSight, and for a living, I do enterprise security management or log analysis and correlation. And somehow over time, what happened to me was that I got kind of bored of the textual log files and parsing and everything, so I somehow developed a passion for visualization, and that's what I want to talk about today. So the rough outline is going to be that I want to introduce the problem very quickly. I'm going to show you what graphing really is and what I mean by that. And then I'm going to show you a tool that I developed over time. And some of you might have seen my talk last year where I introduced Afterglow a little bit. Over the last year, I have made quite some improvements on the tool, and there are new features in there which are quite interesting. And I've gotten some really good feedback from you guys on what I should change and how you're using this tool to actually visualize your own data. And what I want to do in the end, which is kind of the main part, is I want to go through a firewall log file and show you some of the things you can do with it and how you can visualize it. Just to send that up front, and you might have heard that from me already, but I need to do it because of legal issues. IP addresses and host names showing up in event graphs and descriptions were obfuscated or changed. The addresses are completely random, and any resemblance with well-known addresses or host names are purely coincidental. So don't try to play with these IP addresses and think it's me. You're screwing someone else. All right, well, the motivation for doing visualization or looking at graphs is really the question here. What would you rather look at? Do you want to look at the left-hand side or the right-hand side? I prefer the right-hand side because I can't even read the font on the left-hand side. And I guess this is something probably everyone has heard by now, but a picture is really worth 1,000 log entries. And I hope to be able to prove that in the next 50 minutes, if I'm not going over time. All right, so how does graphing work, or what do I mean by that? There are basically two steps, if you simplify it a little bit. You have a device that generates a log file, or maybe events. You record them, and you want to make a visual on the right side, some kind of representation, a bar chart or a link graph or a tree map or something. What you have to do is you take that log file on the left side and you need to parse that thing. You need to figure out where are my source addresses in there, where are the destination addresses, where are the ports. So you need to parse it out and figure out all those things. And then you throw it into an event visualizer, whatever that is. You can use Afterglow, which I will show in a second, and you generate a graph. What I'm going to look at for graphs today is I don't want to cover all the different types of graphs that are out there, or visuals. There's bar charts and pie charts and linear line charts and so on. What I want to cover is just these two types. There are link graphs and tree maps. Link graphs are basically you have a couple of nodes or 3 nodes, and they're connected to each other, and they show you a certain relationship. Tree maps, they look a little complicated when you look at them the first time. You might not quite understand what they are, but I want to introduce them to you and show exactly what they are in a second. Now, if you take link graphs, a lot of times you will see graphs that show you communications between different IP addresses. You see that this machine talked to all these other machines, but the interesting thing is that you can actually reconfigure these graphs to also show you other things in a log file. So what I have here is a snort event. You don't have to be able to read this, but I basically take 5 fields out of this snort event. It's the event name, the IP addresses, and the ports. And there are different ways to configure a graph now. The regular way would be that you take the source address, then the event name, and then the destination address. So you will see things that, what has this IP address done to other machines? However, if you configure this graph a little differently, if you say, well, let's visualize it a way that I have a source address, a destination address, and then the destination ports, you will suddenly see port scans because you see source machine going to some other machine on all kinds of ports. So that you wouldn't see that in the first configuration where you see a source IP, a name, and then a destination IP, because you're not showing the destination ports. So the point of this slide is really you can configure these graphs all kinds of ways, and depending on the configuration, you will see different things. Now, let's have a look at tree maps. And I'm not sure how many people are familiar with those, but they're really useful for a lot of cases. So let's assume this rectangle that I have here is all your network traffic, everything you see on the wire. Now what I want to do, I want to see how many percent are UDP or TCP. Basically, I want to see the transport protocol here. And what I do is I just configure the tree map to use the transport protocol as a parameter. So what happens, I have 20% UDP, 80% TCP, and it just partitions it that way. So 20% in the rectangle is UDP here. Now, if I change the configuration to not just be the protocol, the transport protocol, but I also want to see the service. So what happens then is basically this space is subdivided now, and the protocols are shown inside. So for UDP, you might see things like DNS or SNMP, and this is probably like a ratio of 90 to 10. And then on the other side, the TCP, you see the partitioning to all the TCP protocols you have. So you can set up a hierarchy, and the hierarchy is going to be displayed inside of this tree map. And you could go deeper. I could say now that I want to see the target port or the source IP address, and it will just be subdivided inside of these little rectangles, and it will show the percentage again. And you will see a real example later on what you can really do with this. Now, let's switch over to Afterglow, which you will find either on the CD or on SourceForge. There are two versions right now. It's a little confusing. I apologize for that. There's basically a version 1.x. Currently, the one on CD is 1.5.6. And it's basically a Perl script that generates you link graphs. And then the version 2.0, I started coding in Java, and I used the library, and I thought I would be able to get all the capability or functionality from 1.x into that new Java framework. But it turns out the library I'm using is a little buggy, and the author was not really responsive. I traded a few emails, and so far I haven't gotten any patches for the bugs that I found. So for now, there are two versions, I'm sorry. Hopefully at some point there's a 3.0 which combines everything. So what you will also find in Afterglow is when I started playing with the log files, I needed to write parsers because otherwise I couldn't really visualize my log files. So what I decided to do is the parsers I'm writing, I just put onto the Afterglow distro as well. There are three parsers, one for the BSD packet filter, one for TCP dump, and I updated that to 3.9 recently. So if you're using an earlier version of TCP dump, it might not quite parse it out anymore. And then one for sendmail. If you look at the parsers quickly, they might actually be quite useful, even if you don't want to do visualization. Here's an example of how to use TCP dump to CSV. So what it basically does, you pipe TCP dump into it. That's just a long command line on top. And then you tell it what fields you want to extract from the original TCP dump output. And here, what I said is basically I want to see the source IP, the destination IP, and the source port. And if you want to know the names or the fields that are available, look at the source code. There's a list of all of them. So what this thing also does for you, it takes care of connections. If you look at a connection, or if you look at a TCP dump, and you see a client connecting to a server, you will see a request going over the wire. And the source address is the client, the destination address is the server. But then immediately followed by that, you will see a response. And now the source address seems to be coming